Yes, because I feel like at this point, what we need to do is spend some time practicing things, as we've done quite a bit of concept, and now it's time to like get used to how you're going to be using it. So we're going to need to spend some time doing that. So to recap here a little bit before we start moving forward, the goal has been to be able to factor polynomials, which we could not factor using the factoring tree. That's what we've been working on. So the tools that we've developed so far is we have the factor remainder theorem. And what this allowed us to do is it allows us to use synthetic division to help do that factoring. So if I know one factor, I can use synthetic division to factor the polynomial into that one factor and whatever the quotient is, right? But I have to know one of the factors to be able to to take advantage of this. So the drawback there is that it requires knowing a factor to kind of get started. Yesterday we talked about the rational roots theorem. And what this allows us to do is it gives us possible factors to check. The drawback here is it's possibly still a long list of factors. The third piece that we saw yesterday was using the calculator to find x-intercepts. This gives us an idea of which of our rational roots to check first. So more often than not, in fact, it's going to tell us exactly a good rational root to use. The drawback here is sometimes it's hard to tell if the x-intercept is irrational. We can't distinguish. How do you spell that? Something like this. I'm just going to write it messy so nobody can tell I can't spell it. I don't know. How do you spell it? You think that's it? Okay. All right. I don't know. I'm a terrible spieler. That's abbreviation for between. Okay, so the drawbacks to the calculator, as nice as it is, there are some drawbacks. So if you have an irrational x-intercept, say the square root of 2, the square root of 2 is the decimal 1.41, yada, yada, yada. If all I'm doing is looking at the picture, it's hard to tell the difference between that and, say, 1.5. 1.5 is rational. I can use that to do synthetic division with. Square root of 2 is not rational, so I can't really use that to do the synthetic division with. It's hard to tell the difference just by looking at the picture between two things that are rather close together, if one is a rational number and the other is not rational. The second issue is we can't identify if a factor occurs multiple times. So say that my polynomial factors to x plus 1, and then x plus 3. Just by looking at the graph, I can't really tell if that x plus 1 is being used more than one time, right? But that's something that could happen. And then the third issue is if my polynomial has only imaginary roots, the graph can't really identify any of those. Like the imaginary roots wouldn't show up there at all. But this is a good start, what we've done so far. So let's do one quick example of kind of what we've done so far, and then we'll state one more theorem, talk about how we can use that. It's something we've already kind of talked about first semester. And then I'm going to give you guys some stuff to work on. Okay? So I just wanted to kind of recap what we've established to this point as a process, and then go through that process once more where everything is kind of connected together. Because previously we'd just been kind of like telling a story and incorporating these new techniques as we went in the story. But now it's time to like step back and see it all together, used in conjunction, in a row, so the process looks a little bit more streamlined. Okay? So let's say we have this polynomial that we're asked to factor. The first thing that I'm going to want to do is I'm going to want to use the rational roots theorem to identify any possible rational roots. To use that, I'm going to care about the factors of the constant term and the factors of the leading coefficient. So the factors of 6 are what numbers? Okay. And then my leading coefficient is 1. What are the factors of 1? 1. Okay. So my possible rational roots are going to be plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 1 over 1, plus or minus 6 over 1. Or really, I'd write that as plus or minus 2, 3, 1, and 6. Annalise. So let's do this then. That's a reasonable question. I'm going to just change this example problem slightly. How about that? Does that feel okay? Okay. So I'm also going to then have the list here. So I take each factor of the constant term and divide it by each factor of the leading coefficient. Now, if we look at this list, there are some duplicates on this list. Do you see some numbers written more than once? Yeah, right? 2 over 2 is the same as 1, which I already have written down here. So I'm going to discard that one. Do you see any other duplicates? 6 over 2 is the same as 3, so I'm going to discard that one as well. So if I go and list my possible rational roots, if I reduce everything down, and I just kind of wrote it in, I don't know, some kind of an order there. That's what I would have. That's what I would list. So these are the factors or the possible things that I would want to start my synthetic division with. Right now, it would be just a guess as to which one of these I'd want to use. I don't want to guess. I want to have a more directed idea of what to do. So I'm going to graph this polynomial and use my graph to kind of give me an idea of where to start. God darn it. Okay, so I'm just going to go to the y equals menu on my calculator and type in the polynomial exactly as it's written. Before I hit graph, though, I'm going to set my window. My first window set that I'm going to make is going to, the x min is going to be the smallest number from this list, and the x max is going to be the largest number from this list. What's the smallest number on this list? It's not a half, because everything has a plus or minus associated with it. There's something smaller than negative 1/2, negative 6, right? What's the largest number on this list? Positive 6. So that's what I'm going to set my x min and x max at. Or really probably better would be to pick something a little bit bigger or a little bit smaller than each of those. So maybe I'll do negative 7 and positive 7. Because I want to see like if it's crossing or not. If it's the very last thing on my screen, sometimes it's hard to tell. And now I'm going to hit graph. Okay. So if I look at this graph, I'm going to be looking at the tick marks on my graph and kind of counting them. So the origin here is 0. This first tick mark is negative 1. The next one would be at negative 2. And then negative 3. Everybody agree with that? If I look at the right side of my graph, again, I'm starting at the origin here. The first tick mark here is 1. So the x-intercept here would be maybe a half. Does that feel okay to you guys? So from the graph, I'm interested in x equals negative 2, negative 3, and positive 1/2. Is everybody okay with how I pulled those values off of the graph? Elena? It's wherever we're crossing the x-axis at. Yep, those are the values that we're interested in. Before I go and I start my synthetic division, I want to go back to my list here and just check to see that the values that I'm interested in are on my list. And I see all three of them are on my list. So each one of these would be a good candidate to start my synthetic division with. It doesn't really matter which one of them because they're all on the list, but I definitely want to go back and look at my list and make sure I'm picking something that's from my list. Because it's possible that you get an irrational thing that you wouldn't want to use because it's not on your list. Like if I saw 2.5 or something here, I wouldn't want to use that because it's not on my list. It would probably mean that's an irrational root that I'd want to stay away from. Okay, so let's, for the sake of argument, just say let's start with -2. Mostly just because it was the first thing that I wrote down. There's nothing special about -2. Any one of them would work. Although if you asked me, I would probably avoid the fraction because, well, fractions, right? All right, so I start my synthetic division. And that works. So from this, what I can say is that this factors to x plus 2 times x squared, 2x squared plus 5x minus 3. Everybody okay there? Now, I could do one of two things here. I could try factoring this by hand, or I could try doing another round of synthetic division with my quotient. Either is fine, because we haven't gone and done the second synthetic division. Let's do that one. So I've already used -2 for my list. So for this next synthetic division, I'm either going to use -3 or +1/2. I'm going to pick -3 because, well, it's not a fraction. It just makes the arithmetic a little more convenient. So I'm going to just do that and write it like this. You could recopy it into a whole separate synthetic division thing, but this is the way I like to do it, where I just reuse whatever's at the bottom because I can't recopy it wrong when I copy it a second time. It just, like, I only have to do it right once. So again, I get 0. So what I can tell from this, the x plus 2 is still there. And then this piece becomes x plus 3, and then 2x minus 1. And there's my fully factored polynomial. Is everybody okay with that idea? Elena? No, you could have, this quadratic, it turns out, is factorable by hand. You could have used the long factoring method on that. But it's possible that what you get here is not going to be factorable using the factoring tree, and you'd have to do another synthetic division until you get something that is factorable using the factoring tree. So that can happen. Jack? Assuming that the things on your list are actually rational roots, yes, it will work. Annalise. Right. So why that happens is because really what we have here is x equals -3. And if I add 3 to both sides, I get the factor x plus 3. So that's why that's giving me the factor x plus 3 as opposed to x minus 3. Right, because Right, because to set up my synthetic division, I start by setting that divisor equal to 0 and solving. And that gives me x equals -4, so I put the -4 out there. Right? The calculator, all we graphed was the polynomial. We didn't have to do any sign changes when we did the graph. So what we're finding here, if I go back to the very first day, we looked at, where is it? Oops, it's up here. We looked at this relationship here, that the factors were related to the solutions that were related to the x-intercepts and related to the zeros. Notice here, if I look at the factors, I have x plus 4. I have the solution x equals -4. I have the x-intercept -4, 0. And I have the 0 for the function as -4. So any of the other three, to recover the factor, you have to like add it back to the other side, I think is what you're asking, right? Did I get it? Okay. And you're good? Okay. Good question, though. Certainly understanding like when you're flipping, when you're kind of changing the sign and why we're having to change it definitely matters, right? Definitely matters. So good. Okay. It's time for you guys to try some of these on your own. So I have a handout here written up for you guys. Unfortunately, I didn't want to use like a million sheets of paper, so there might not really be room enough on this sheet for you to do all your work. Just as an FYI, I have to do this on a separate sheet of paper, but I figure it's more convenient to at least have the sheet in front of you so you don't have to monkey with OneNote or whatever while we're doing this in class. If you'd like to work with one other person just to kind of talk about what's going on and what you're doing and why you're doing things, check your work against. That's perfectly fine. If you get stuck on things, please come up and talk to me. I'd be happy to talk to you about what's going on and point you in the right direction or fix whatever your mistake is or any of those sorts of things. If you want to check your work against things, feel free to come up and talk to me. I'd be happy to let you check against the answer key. Okie doke. And this is what we're going to be working on for the rest of the hour. So if we finish early, we can reassess. But I think you guys need some time to just kind of work through this process a little bit. Make sure one of you has a graphing calculator. You definitely need to have that out because you have to look for those x-intercepts.